Hello guys, 2D particle equilibrium, but at the end I'm gonna just comment a little bit about this problem, how you can solve it if you know uh, 2D rigid body equilibrium, which is the next chapter that we will cover. For the time being, remember, if you do this uh, particle equilibrium, we need two unknowns, maximum in 2D, summation of forces in X, summation of forces in Y equals 0, and we know this force of AF or this tension is going to be the same force as the bucket, which is here, and the bucket is 60 kilograms, remember, multiplied by 9.81, and that force will be 60 times 9.81, that will be 588.6 Newton. That will be that force that we have over there. Now we go to the particle A, basically here we have AB. Remember, tensions always go out from the particle. This is the particle A. This is AC, and the weight here 588.6 Newton. So basically we need the angles in order to do this decomposition, and if I calculate this angle alpha here, I can say this is 3, this distance is 4, meaning this is going to be 5, so I can either calculate the angle or use 3, 4, 5. So I like using 3, 4, 5 if I can. 3, 4, 5. But if you want to calculate the angle, it's just inverse tangent of 4 divided by 3. Now let's do that. If I do summation of forces in X, remember we have summation of forces in X equals 0, summation of forces in Y equals 0. Two systems of equations, two unknowns. If I do summation of forces in X, I have this component and the X component of this one, meaning two unknowns in the same equation. I'm not going to start doing that. I could, and I'm going to get the answer, but it's going to take more time. More time, not only, more time and more writing. And the more you write, the more opportunities for messing up the problem you have. So basically, if I do now summation of forces in Y equals 0, the only thing that I have acting in Y, unknowns, I mean, is this unknown, the Y component of AC. So I'm going to start by doing summation of forces in Y equals 0. And how do you calculate this component? If you have the triangle, same, the parallel side of the triangle, so 4 over 5 divided by the hypotenuse, 4 over the hypotenuse multiplied by AC, positive because it's pointing up, minus 588.6 equals 0. Now remember what you are doing here, and I like repeating it. It's just a triangle ratio. So remember, you have a small figure here, 3, 4, 5, or a geometric figure, 3, 4, 5, and then you have a triangle of forces here. You have this, this, and that. This is AC. This one here, I'm going to call it ACY and ACX. So if you have these two triangles, and those are similar triangles, basically you can say 4 divided by 5 is equal to ACY divided by AC. That's what we did here. You can say 4 divided by 3 is ACX divided by ACY. ACY divided by ACX. You can do that. You can even go ahead and say 5 divided by AC equals 3 divided by ACX. It doesn't matter as you compare this side with the other side, and you're gonna get the answer. If you don't like that, then calculate alpha and use sine and cosine alpha. You can do this by saying 4/5 AC, or you can use the same thing but saying sine alpha AC, sine alpha AC, and remember alpha is just the inverse tangent of 4 divided by 3. But I stated like that. I'm going to solve it like that. You feel free to do it in any way that you see fit. So basically we have 588.6 multiplied by 5 divided by 4 is negative. So when I pass it to the other side, it's going to be positive 7 735.75 Newton. Good. And now I know this force. What do we do now? Now we can say summation of forces in X equals 0. And what do you have in X? You have this component of AC, negative. Why negative? Because it goes to the left, negative. And what is this value? Either cosine alpha multiplied by AC or 3. Why 3? Because it's the same side, parallel side. 3 over 5 multiplied by AC. But remember, now we know AC, and this is negative because it goes to the left, plus AB equals 0. I get this term, pass it to the other side, and solve for AB, which is going to be positive. AC is this value that we got before, times 3 divided by 5. That's 441.45 Newton. Good. So we know this, we know this, we know this. The only thing that we have to do is going now to C. This is C. And you have the free body diagram will be CD, CE, and CA or AC. But this value CA or AC, we already know it, 735.75. And we need, of course, the angle, alpha, this angle, or, once again, we can use the 3, 4, 5 triangle for this force. That will be it. Summation of forces in X or summation of forces in Y? Which one? Okay, if I do summation of forces in X, I have only this unknown. And if I do summation of forces in Y, I have only this unknown. So in this case, it's irrelevant. I'm going to say summation of forces in X equals 0, which is this one. That will be negative CD plus the X component of this force. That will be 3 over 5, 3 over 5 times 735.75. Pass CD to the other side, and CD will be 735.75 times 3 divided by 5, 441.45 Newton. And we can do now summation of forces, well, now and before. In Y equals 0, that will be CE minus this component. So let's start with CE, positive, because it is pointing up, minus this one. Remember, parallel sides, so 4 over 5 times CD equals 0. And then you can solve for CE. I say CD here, now CD, 735, whatever, that's it. So these values, 735.75 times 4 divided by 5 is negative here, times 4 divided by 5, not times 5 divided by 5. That will be CE equals 588.6 Newton. And that will be it. Every single problem is solved in that way. Now, at the beginning, I mentioned something about, let's suppose that you already know moments and rigid body equilibrium. So look what happens here if you know that. You know this value, 588.6 Newton. Perfect. Now, if you know free body diagram, there are tons of things that you can do here. Let's say let's say that I take this rigid body and I have this tension here, CE. Don't worry too much at this stage if you don't understand this, but you will understand this. And this is CD, and this is AB in this case. Now, look what is happening here. If I select that as my free body diagram, I can say summation of forces in Y equals 0. When we do 3D or 2D rigid body equilibrium, you have three equations. Summation of forces for equilibrium that must be satisfied, and summation of moments equals 0. So if I select here in this free body diagram, summation of forces in Y equals 0, I can get that CE minus 588.6 equals 0. So CE will be 588.6 newtons, which is, surprise, the value that we got by doing summation of forces and doing particle equilibrium. Now, let's say that I would like to calculate what is the value for AB or even CD. Then we will do something that is called summation of moments, which is going to be covered later on. But just like a preview, I can select summation of moments at C equals 0. A moment is just a force times a distance. It's like a torque. So the force is vertical, the distance is horizontal, and if the force is horizontal, the distance is vertical. So if I select to do summation of moments at C, and I use this side, then what is going to happen is this. I'm going to have, and assuming this rotation as positive, you will have 588.6 times 3, vertical force, horizontal distance, rotation clockwise, meaning negative here, plus AB times horizontal force, vertical distance, 4, equals 0. And these two don't produce any moment because I'm taking moment exactly at that point. And I could solve for AB, and AB will be basically this times 3 divided by 4, and that will be 441.45 Newton. AB 441.41 Newton, 45 Newtons. And if I stick to the same free body diagram here, and I say summation of forces in X equals 0, then you have negative CD plus AB, there's nothing else, equals 0. So CD equals 441.45 Newtons, which is the same 441.45 Newtons that we got here before for AB and for CD. And if I want to find this one, I can use particle equilibrium if I wanted to. But once again, don't get frustrated if you don't understand too much what I'm talking about here. But as soon as you hit the chapter for moment, go back to this and review, because that's going to help you in your second midterm. It's going to help you in the final exam. At the end of the line, it's going to help you in all of your engineering life every time that you have to do a problem involving these type of situations. Bye guys, be good, and I'll see you or you'll see me next video. Have a good day.